Hi and welcome to lesson 10. By the end of this lesson, you will have finished the war card game project. All that's left to do is to count the score and to update the label elements on the storyboard. Now, doing this is going to involve writing Swift code that can take two numbers, compare them, and then execute different branches of code depending on what the result is. In other words, you're going to be writing Swift code that can make its own decisions. Furthermore, by completing this project, I'll tell you where to get your certificate of completion for your achievement. And yes, I'll even send you a physical paper copy of it if you want. All right, you ready? Let's do this. So before we dive into our Xcode project, I want to first start in a playground, and I want to show you what's called an if statement, which is going to allow you to evaluate a piece of data and decide what to do. So the if statement starts with the if keyword, and then you're going to test some sort of condition, whether it's going to be true or false. And so I've got a constant integer, x. It's set to 10 right now, so I'm just going to do a simple check and say if x is less than 11, okay, so that's my condition. It's going to make that test. If that is true, then it's going to run the code in between my curly brackets. So let's create some space in the middle, and I'm going to print hello. And let's run this code here. And it's going to take a while. Okay, so we see hello in the console. The reason this executes is because this condition is true. Right? However, if let's say x is 12 and I run the code again, nothing's going to be output down there. It doesn't run this code because it checks and it fails the check. So here's the cool thing about if statements, and that is that you can provide alternatives. So you can say if x is less than 11, then print hello. Otherwise, and you would use this else keyword, and you would specify another block of code to execute. Print goodbye. All right, so if we ran this code right now, what would you expect to be output? All right, goodbye, because it does this check and it fails it, so it doesn't go in there, and instead it comes into this else part. So let me just set this to 10 and show you. So x is less than 11, and that's true, so it comes in here and prints hello, but it doesn't print goodbye. It just chooses one path or the other. Now here's some other cool stuff that we can do with an if statement, and that is to test multiple conditions. So we can say else space if and open up another block. So let's say good afternoon. Oh, I forgot to put the condition here. If x is, let's say, greater than 12, that would print good afternoon. Let's make this number a little bigger. So let's say 15. If x is greater than 15, then print good afternoon. So what if we made this guy 20? So it would basically start at the top. It would check if x is less than 11, and it's not, so then it checks the next one. Is x greater than 15? Yes, it is. So it prints, it executes that code in there, and it skips the else clause. Now, what if none of it is true? So what if I said x is equal to 13? Right, so let's give that a run. It falls down to this else clause because this wasn't true, this wasn't true, so all that's left is this sort of catch-all bucket. Now here's the cool part. You can omit different pieces of your if statement depending on what you want to do. For example, you can remove the catch-all bucket. You erase that and you execute it. Nothing happens in this scenario because none of these conditions are true and there's no catch-all bucket, so essentially no code gets run. Now so far I've just done less than and greater than, but you can also do a couple of different things. You can do less than or equal to, right? You can put an equal sign, or you can do greater than or equal to. You can also do not equal to. So not equal to is actually exclamation mark equals, and that is testing if x is not 11. So let's take a look at this. And we get hello. Now here's a very, very important point, and that is that only one branch of your if statement ever gets executed. So if I had this statement where I was saying, let's say something like that, and I ran the code, both of these conditions are true, right? But it starts at the top, and as soon as it reaches a true condition, it will execute that block of code, and that's it, right? Your if statement is done. So it ever only picks one path to go down, even if this would have evaluated to true. Now this is very different if you write this, because if you did it this way, these are two different if statements. So it would first run this if statement, right, and test its condition to see if it should run this block of code, and then it treats this as a separate if statement, and it's going to test this condition to see if it should run that block of code. So that is one clear distinction to make, right? Doing it like this, if and then else if, combines these two conditions into a single if statement. So it's going to be like two different paths, and it's going to choose one path. Now instead of having two different branches like we have here, you can also do 3 branches or 4 branches. You can just keep chaining these else if things if you want. Something like that. No, that doesn't really make sense, but so you could chain as many of them as you want, but just keep in mind that it's going to start at the top, work its way down, and as soon as it hits a condition that's true, that's the branch it's going to take, and it's not going to execute all your other branches. Now, I wouldn't go too crazy with having a whole ton of else ifs, because there's actually another it's called a switch statement that is more suited if you have a lot of different options. But an if statement is good if you want to just test a couple of branches. And what else can I show you here? So let's talk about the different types of comparisons that we can do. We can do, as you've seen, greater than, you've seen less than, you could do greater than or equal to, you could do less than or equal to, and you can test equality. Now notice that equality is double equal sign. Okay, so this is testing if x is equal to 2. We don't use a single equal sign because remember from your basic Swift lessons, a single equal sign is assignment. If you write this, you are trying to assign the integer 2 to the constant x, right? And this is an error because x is a constant, so we can't change it after anyways. So if you want to compare to see if x is equal to 2, you would use a double equal sign. And if you wanted to compare, if you wanted to test that x is not equal to 2, you would say exclamation equal. And this is testing if x is not equal to 2. Now this stuff can get pretty crazy because let's say you had another constant here, and we're not going to need to do this with our word card game, but I still want to show you, just it's good to know. So if you wanted to test a condition with 2 different variables, you can either say and or. So and is double ampersand like that. So for me that would be shift and 7, I would get the ampersand, so your keyboard layout might be a little different. So I can say, if y is equal to 5 and x is greater than or equal to 11, then that would be true. Now when you use an AND operator like we have here, both sides of this must be true. Only then will it come into this branch. So if we had something like y equals to 6 like that, and we ran this code, then it would jump down to here, right? Because this is not true, and that kind of like cancels the whole thing. The whole thing evaluates to false. On the flip side, let's say we had something like OR, which is actually represented by these 2 double pipes. For my keyboard, that would be shift and backslash. I get this sort of symbol. So for your keyboard, it might be a little different. But this represents OR. And when you have an OR operator, either this evaluates true or this evaluates to true, and that would be sufficient for it to go down this path here. So as you can see, if I run this code right here, we're going to get hello. And that is because even though this is not true, this is true, right? And that's enough because we're using OR. Now here's the crazy part, and that's that you can use brackets to chain these things together. So you can do something like this. So you can say, like, if x plus y is equal to 10 and either this one or either this one is true, then come down here. So you can express some pretty complex logic depending on where you place these brackets. So let's try to run this code here, and we get good afternoon, but how will we make this work? So x and y have to equal to 10, y has to equal to 6. So if we just did that and we changed this to 4, that would actually bring us into hello. So why does this evaluate to this branch? Well, because x plus y is equal to 10, right? Is it? 6 plus 4 is 10. And because we're using the AND operator, this side must also evaluate to true. Now, what does this side say? Well, since it's using an OR, either this must be true or this must be true. So x is not greater than 11, right? It's 4, that fails, but y is equal to 6, so that's true. So essentially this side is true and this side is true, and so that's why we're going down this path here. So now we're going to implement an if statement inside of our Xcode project. Now let's look inside the viewController.swift. Inside the deal tapped, we so far have been changing the image, but we have all the data we need to determine if the left side is the winner or the right side is the winner. See, we have left number and right number, right? And based on what you've just learned on the playground, we can just compare these two numbers. So we can say if left number is greater than right number, then left side wins, or player wins, right? Else if right number, let's actually keep it consistent. So left number is less than right number, then we have right side wins. And then we do have another scenario, right, where left number equals right number. So we can just use an else, and we can say tie. Now I'm not going to address this particular scenario because I'm not exactly sure what to do, but if either the left side wins or the right side wins, we can increase the score and then we can update the labels. So if you remember all the way up here, we actually haven't declared any properties to keep score. So why don't we go ahead and do that? Var left score is equal to 0 and var right score is equal to 0. So they both start at 0. You scroll down here and we're going to say left score, and we're going to use plus equals 1. Essentially that takes whatever number is currently inside left score and we're going to add 1 to it. And we're going to then assign, or rather update the label. So we do have a reference to the label because we have an IB outlet property called left score label. You can see it's a type of UI label. And if we use dot notation, we can access the properties and methods of that score label object in the storyboard. And it actually has a text property that expects a string. So we're going to assign a string to it. The problem is that left score is an integer. So if I try to put left score, see it's an int. If I try to assign left score to update the text of the label, we're going to get an error because it says it cannot assign a value type of int to a type of string. Because remember that the text property is expecting a string data. So what we can do is we can actually create a new string object like that, and it just has a special way where you can pass in an integer and you can represent that integer as a string. So that's essentially what's happening here. We are creating a new string object, and we're passing in this integer, and it's going to essentially treat that integer as a string, or change or convert that data type. Now let's do the same thing with this side. So we're going to say _score is +=1, increasing that score, and then we're going to say _label.text is equal to new string object, and we're going to pass in _score. All right, so let's run our project now and just take a look at what we've got. We've got our card game here, and king is bigger than 3, so we have that increased score. 9 is bigger than 7, so we have 2 now. Gets 1 on the scoreboard. Ace is bigger than queen, so you know, cool, works. Now don't forget to go back and write yourself some comments. Get into the habit of doing this. So we've got randomize some numbers, update the image views, compare the random numbers. And you know, you can get as granular as you want with this. Yeah. Now the last part I want to show you is about running this app on your own phone. So in order to do that, you would just plug in your phone with a cable, plug it into your computer, and if it's the first time you've ever done this, you'll probably get a pop-up, like if you have Xcode open, asking, do you want to use this phone for development? And you have to click yes. When you do that, it's going to set up your phone for iOS development so that you can run this project on it. And also, if it's the first time you've ever plugged in your phone or your iPad to your computer, it's gonna ask on your phone, do you want to trust this computer? And you have to click yes or trust, whatever shows up on your phone. So those are the two things that have to happen. And then once you do have your phone connected and it's got the proper permissions and everything, if you pull this drop down, you're going to see here, I don't have a device connected right now, but you're going to see your device here. It's going to be like your name, whatever you've named your device, essentially. You're going to see it here. You're going to want to choose that. Okay, so this pops up for me because I don't have a device connected, but you're going to want to choose that, and then you're going to want to just click run. And essentially, instead of launching the simulator, it's going to launch this app on your phone. And then after that, you can stop your project, disconnect your phone, and you'll still have that app on your phone. Now, the thing is, when you do it this way, Apple intends for you to do it only for testing purposes. So I think it gives you about 7 days before it won't launch anymore, and you're going to have to connect your phone again and kind of like run your project on your phone to give you another 7 days. If you do have an Apple developer account though, and this is like a paid account that Apple charges you a fee every year for you to publish apps into the App Store, then you'll be able to keep your app on your phone for a lot longer. You'll also be able to send that app to other people's phones for testing purposes, and also to publish apps into the App Store. Not bad, right? Look at how far you've come. Seriously, give yourself a pat on the back. You've just gone through 4 hours of iOS training, not including the exercises, and you've built your first app that you can show people. To celebrate this huge milestone, I want to give you a certificate of completion. Just visit the link below or check out the description and get your certificate and get your name up there on the wall of success stories. Now, in terms of what to learn next, I have several options for you. Number one, you can visit youtube.com/CodeWithChris to see all of the other free content and tutorial series that I have that you can watch. Number two, if you have an app idea, make sure you go and get my free 7-day app action plan, which is going to help you put together an actionable list of learning objectives to build your app. You can get that by going to codewithchris.com/action-plan. And number three, if you have some budget to spend, you can check out my paid courses, which actually continue from the 10 lessons that you've just watched and continue building your skills and building apps. And to check those out, visit codewithchris.com/beginner course. And lastly, I just really want to thank you for learning with me. You know, I never imagined myself teaching iOS, but I'm having so much fun every day, and I feel so fulfilled hearing your success stories. So if this training has helped you out in any way, please reach out and message me and let me know. If it weren't for people like you, I wouldn't be here today. So thank you again. All right, I'll see you in the next lesson.